Hello and welcome to this tutorial. My name is Fadi Abaid. I work as an adjunct graduate teaching assistant in the College of Computing and Information Technology, Arab Academy for Science and Technology in Alexandria, Egypt. In this video we'll talk about neural networks, but first we'll give a brief introduction about the perceptron, which is the building block of the neural network. Then we'll explain how the neural network is trained. The perceptron is the building block of the neural network. It is analogous to a brain cell or a neuron. Perceptron is usually used to classify data into two parts with probabilities. Therefore, it is also known as a linear binary classifier. The input is represented as a vector x. Weights show the strength of the particular node, and a bias value shifts the activation function to the left or the right. In this tutorial, they are all together combined as a vector w, where w0 is the bias. The first value of the input vector x0 is a constant 1 to be multiplied by this bias value. A weighted sum, denoted by S, is obtained by multiplying the input values by the corresponding weight vectors and then summing up them together. It is the dot product of the input and weight vectors. The activation function f maps the awaited sum to the required output values. For example, the output can be in the range of 0 and 1. Here we see the formulas of the perceptron. The input is represented as a vector x, where the first value x0 is the constant 1 corresponding to the bias unit, and the input values are from x1 to xn. Then we obtain the weighted sum by getting the dot product between the vector x and the vector w in this formula. The out predictions can be obtained by applying the activation function f to the weighted sum s to obtain the prediction vector the y hat. The objective function e is the error. It can be measured by squaring the difference between the prediction y hat and the ground truth labels y, then multiplied by a constant half. To map the input to a specific range of output values, we utilize activation functions. In neural networks, there are some common activation functions that are used such as sigmoid, hyperbolic tangent function or tanh, ReLU function or rectified linear unit, leaky ReLU. Sigmoid function is used for the final output. It gives output probabilities between 0 and 1. Other functions are used in the hidden layers. Some are more efficient and more frequently used, like ReLU and leaky ReLU. The learning process is an iterative process that seeks to minimize the objective function e. It subtracts the gradient or the partial derivative of the objective function e with respect to the weight I from the weight wi of each node. The gradient is also multiplied by a learning rate alpha, which is a small value between 0 and 1. The process is then repeated until the error is at minimum. This weight update algorithm is called the gradient descent. The gradient is the partial derivative of the objective function e with respect to the weight wi. It can be calculated using this chain rule formula from calculus. Neural networks consists of many perceptrons arranged in layers. Each perceptron is a node of the neural network. The leftmost layer is the input layer, and the rightmost layer is the output layer, and the layers between are called hidden layers. Input layers correspond to the user input. Output layers correspond to the ground truth labels. The neural network can be trained by a process called backpropagation, as we'll see in the next slides. In the backpropagation, the error is propagated from the output layer to each node of the network. Like the perceptron, the weight of the node is updated iteratively to minimize the output error e. First, we calculate the gradient that maps the gradient of the weight that maps the hidden layer to the output layer. Its name is w subscript I. We calculate this gradient by this formula, where h subscript I is the value of the hidden node I. Then we calculate the error signal, epsilon, which is the partial derivative of the error to the hidden node value and is given by this chain rule formula from calculus. The error epsilon is used to calculate the gradient of the weights of the in the previous layer wj according to this formula, and the weights can be updated by subtracting the gradients from the weights incrementally by the gradient descent algorithms as we was explained before.